Prime-Bonacci ratio needs to be broken down into two things. First and foremost, prime numbers. Well, prime numbers are basically any number that can go into itself and that one can go into. Okay, so for instance, when you get to 5, 5 can go into itself, 1 can go into 5 times. But 2 can't go into 5 evenly, and 3 can't go into 5 evenly, and 4 can't go into 5 evenly. Therefore, it's a prime number, 1 in itself. We'll go to the next one. The next one's 11. Okay, so 11 goes into 11 evenly, and 1 goes into it 11 times. But there's no other number that goes into 11 equally. And so therefore, it's a prime number. So as you continue doing this, you have 3, and then you have 11, and then you have 19. And what's really cool about it is when you dive into it, you'll actually see that prime numbers end in a 1, a 3, a 7, or a 9, unless they have a digital root of 3, 6, and 9. So it's kind of like getting into what Tesla was talking about. So these are prime numbers, and they keep going and going and going. So as you can see, if you get into the 20s, you're going to see quite a few numbers that would actually end up being prime. So it stays very stable. And this is very important. Prime numbers are stable numbers. That's how we want to look at them. That's how we want to actually apply them to this. Okay, so now that we have the prime numbers, now we need to talk about the Fibonacci numbers. So Fibonacci is basically a sequence of numbers that when you start with 0 and 1, you just keep adding. That's all that it is. 0 plus 1 is 1. And now you just go back. 1 plus 1 is 2. And 1 plus 2 is 3. And 2 plus 3 is 5. And 5 plus 3 is 8. And 8 plus 3 is 13. And 13 plus 8 is 21. And it just keeps going and going and going and going. Now, as Fibonacci numbers get bigger and bigger, though, they get exponentially larger. Okay. By the 12th Fibonacci number, you're already into 144. And by the 216th Fibonacci number, you're actually into a quadrillion number. That's how massive these actually get. It's one of the reasons why when we try to apply Fibonacci to a market, it's very difficult unless you know a couple of keys, like the 60-digit repeat pattern, the 24-digit digital root pattern with Fibonacci, the Lucas sequence. Any of these would actually help you limit this down. Okay, so let's talk about it. We have prime and we have Fibonacci. Now, anybody that has studied prime numbers really didn't want much to do with Fibonacci numbers because there was no correlation between the two. And anybody that dove into Fibonacci didn't really do too much with prime numbers because, again, there was just no correlation. So you either spent most of your life studying one or most of your life studying the other one. Okay. And so that's where this gets really interesting, is that it turns out they have a lot more to do with each other than what we actually thought. Okay. And that's where the Prime-Bonacci ratio comes in. You see, each number that actually exists can be broken down into part of a prime number plus or minus part of a Fibonacci number. Okay, so let's go ahead and start and pick a number. So let's go ahead and start with, let's say, number 3. Okay, well, 3 can be expressed as 2, which is prime, and 1, which is Fibonacci. Okay, 4 can be expressed as 2, which is prime, and 2, which is Fibonacci. Let's jump down a little bit instead of just sticking with the single numbers. Let's go into 12. Well, 12 can be expressed as 7, which is prime, plus 5, which is Fibonacci. Let's jump down even further. Let's go to 21. 21 can be expressed as 13, which is prime, plus 8, which is Fibonacci. Let's go to 55, right? 55 can be expressed as 47, which is prime, and 8, which is Fibonacci. Let's keep going. Let's jump into the hundreds, right? Because this is not, I'm not explaining this in terms of saying that almost every number, literally all the way to 100, every single number fits Fibonacci. So let's jump into up to 200. So we'll take 137. Well, 137 can be expressed as 7, which is prime, minus 144, which is Fibonacci. So as you can see, every number is broken up into a prime number plus or minus a Fibonacci number. And what's so amazing about this is that it turns out I'm saying almost every number, because when you get, so every number in the 100s, 200s, 300s, 400s, but once you get to 551, I have what's called my first outlier. It was the very first one that did not fit in. So imagine how long it took me to get to this actual place. So we're going to go to 552 to explain to you that it seems like it fits right in there. So 552 can expressed as 463, which is prime, plus 89, which is Fibonacci. 550 can be expressed as 173, which is prime, plus 377, which is Fibonacci. But when you get to 551, it's an outlier. There's nothing that actually fits in. Now, if I continue counting and I get to 610, well, that changes the game just slightly, because when I actually get to 610, now I can find out that 59, so I can go back to 551, 59 minus 610 ends up being 551. Well, 59 is prime, 610 is Fibonacci. You see? So what's really interesting about the outliers is as you continue expanding the container of numbers to bigger and bigger and bigger ranges, the actual outliers correct themselves. So I ran this on multiple tests all the way up to 1,000,000 numbers. And what I found is I found that as you continued expanding the container, the numbers, the outliers would correct themselves or recalibrate themselves, but creating new ones at the higher numbers, always staying below 1%. The outliers never cross the line of 1%, which is why I say almost every single number in our existence is made up of part of a prime plus or minus a Fibonacci number. Now, the reason this is so amazing, right? So we'll put the numbers aside for a second. The reason this is so amazing is because we did not create prime or Fibonacci numbers. Because prime and Fibonacci numbers have existed for a very long time if they were found in every single number, right? If Pythagoras was playing with numbers, prime and Fibonacci existed, we just didn't know it. It's like having a door in front of us we'd never seen before. So think about that for a second. We didn't actually create Fibonacci numbers. We discovered them. They were always here. And we didn't create prime numbers. We discovered them. They were always here. And yet, when I went out to go find if anybody had been talking about this, if anybody had any information to help me where I was, there wasn't a single paper published. There's nothing whatsoever about this, which is why I jumped on it, got my paper in, started the patent, because I understood prime numbers. I understand that our encryption currently right now is based off of prime numbers. If you do a little bit of research and you study Goldbach's conjecture, again, physics, or you can watch The Big Bang Theory. But if you end up studying this, you'll find out that every single even number after 3 is actually made up of 2 prime numbers. Okay, so again, no Fibonacci mentioned. He found out that every even number after the number 3 was actually made up of 2 prime numbers. And this understanding is what our whole entire encryption system is based off of. Once we knew this information, we started creating passwords and codes that followed this level of understanding. So to find something that is far beyond, because even if you take just even numbers, you have a whole nother set of odd numbers this doesn't work for, which is roughly anywhere between a 50 to 60% accuracy. But when you apply the PrimeBonacci ratio, you actually find a 99.27% accuracy, that every number can actually be made up of a prime and a Fibonacci. And since we did not create these, but discovered them and found them and started working with them, it tells you that all the way back to the beginning of existence, the beginning of someone counting for the very first time and choosing a number, shows that these numbers actually existed all the way back to the raw material. Okay. And so understanding this was absolutely profound. It's profound on a mathematical level. It's profound on a spiritual level. It's profound on a awareness and present moment level. Because what that was telling you when I was talking about the range expanding is that you're hitting a wall. And as long as you expand, as long as you stay in the present moment and expand your moment, you then can actually fix your own outliers. If you think about it, outliers are just moments of chaos. And so therefore, whenever you have this outlier that happens, if you would have stayed in the present moment, if you would have done what Deepak and Eckhart Tolle have been talking about, you wouldn't actually experience that outlier as an outlier. It wouldn't be chaos. There is so much here to unpack. There is so much information to unpack. Okay. One last thing I want to talk about before I wrap this up is let's go ahead and take it scientifically. All right. There are a lot of things that Terrence Howard said in his video that I don't align with. And that's not an insult to him in any way, shape, or form. I just can't connect to it. I've tried numerous times. For instance, 1 times 1 equals 2. Only because of the fact that his comprehension of 1 times 1 equals 2 is only confused because he doesn't understand multiplication. Multiplication is not its own entity. It's just a more expressive way to be able to talk about addition. Okay, so it's not 2 times 2. It's 2 times. Okay, so therefore 1 times 1 is actually just 1 time. Well, if you have 1 and it's 1 time, it's still going to very much be 1. If you have 2 and you have it 2 times, then you have 4 because you had 2 plus 2. Okay, so there are quite a few things that we don't really align on in that area. But one of the things I really do align on and really liked is the understanding that this whole universe is made up of 2 energies. There is electric energy and there is magnetism. And if you study Coral Castle, you'll see a man who really mastered the understanding of the magnetism. And if you study the Bible, you'll end up understanding electricity. And so the understanding to think about it is magnetism is going out, but doesn't really come back in. And electricity goes out, but actually comes back around. Okay. Now, again, let's go back to talking about the Prime-Bonacci ratio and what I told you in the very beginning about prime numbers. Prime numbers are stable numbers. They're the most stable numbers. And you see this one right here. What this is actually showing you is it's showing you that the prime numbers are the most stable throughout this process. The Fibonacci are very spread out. Okay. So if the prime numbers are stable and we know that magnetism is more stable, we can apply and see that prime numbers represent magnetism. Therefore, Fibonacci numbers would represent electricity. And that works very well because, again, it goes out and it comes back in. Well, that's exactly what Fibonacci does. Fibonacci goes out and then it comes back in. And in fact, it starts that way. 0 and 1 is 1, but then that 1 has to go back to the one before it. 1 plus 1 is 2. And then that 2 has to go back to the one before it. 2 plus 1 is 3. So it's constantly going out and coming back in. But if you get into the 60-digit repeat patterns, or you get into the 24-digit repeat patterns, both of those, shout out to Lucius Kahn and also Jan 108. So whenever you start working with those, what you see is you're constantly reverting back because it's creating cycles. Okay. One's electric, one's magnetic. And what's really fascinating, I'll leave you with this question is, if we know that everything is made up of electricity and magnetism, which creates our quantum field, then what is actually happening at the number 551 for the very first time that causes an outlier? And to make it just a little bit more fun for you to really kind of think on this, 551 minutes is 9 hours and 11 seconds. Get your 9 vibes aligned.